Question 1b, it says write down giving reasons, the size of angle CMA, which I'm marking here, and hence determine the equation of line MC. Now we are told that AMCO is a cyclic quad, which I have marked off in red, and of course opposite angles of a cyclic quad add up to 180. It means that angle CMA plus the angle at the origin, which is 90 degrees, is equal to 180 degrees, and the reason will simply be opposite angles in a cyclic quad. So angle CMA will just be 180 minus 90, and that's going to be 90 degrees. So that's a right angle there. And this simply means that the product of the gradients of line MC and AB will be -1. So we could calculate the gradient of line AB if I use the gradient formula. So again, I will call the coordinates of A, x1 and y1, and of B, x2 and y2. So now we will calculate the gradient of line AB, and that's going to be y2 minus y1 over x2 minus x1. That's going to give me y2 is 0 minus y1 is 6 all over x2 is 12 minus x1 is 0, and that's going to give me -1/2. We can now say that the gradient of AB multiplied by the gradient of MC is equal to -1, and the reason will be perpendicular lines. So the gradient of AB is -1/2 multiplied by the gradient of MC, which I can now calculate, will give me -1. If I divide both sides by -1/2, we're going to get the gradient of MC is equal to +2. And now to get the equation of MC, we will now say y is equal to mx plus c. M is 2, so y is equal to 2x plus c. And we can now sub in the point M, which, if you recall in question part A, was 6 and 3. So 3 is equal to 2 into 6 plus c. And if I solve for c, c will be equal to 3 minus 12, which is -9. So the equation of MC becomes y is equal to 2x minus 9.